The function that we're given in Math Problem 5 may look a little bit more complicated, but this is really still just going to be an application of the same ideas that we've used in all the problems so far. So we still want to start by identifying our interior function. So in this case, we have the natural log of 1 plus e to the x being raised to the third power. So we've got some function or expression being raised to the third power. But our interior function in this case is actually a composite function itself. For right now, we're not going to worry about that. Right now, we're just going to take the derivative of this function based off our power rule, since what we have is something being raised to the third power. So we start off with h prime of x is going to be 3 times the natural log of 1 plus e to the x squared, then times the derivative of the natural log of 1 plus e to the x. So this part's done, unless we can multiply something together with that 3 at the end. So what we need to focus on is finding the derivative of the natural log of 1 plus e to the x. Like I said, that's already a composite function. In this case, we're taking 1 plus e to the x and plugging that into the natural log of something. So in order to take the derivative of the natural log of 1 plus e to the x, we're going to take the derivative of the natural log of 1 plus e to the x. So apply the chain rule a second time to just this part of the problem. So this is going to become 1 over 1 plus e to the x times the derivative of 1 plus e to the x. So the derivative of 1 plus e to the x will just be 0 plus e to the x, or e to the x over 1 plus e to the x. So what we did was apply that general power rule, or the chain rule. Then to take the derivative of this last component here, we had to apply the chain rule again, or if we just want to think of it as that general property for differentiating natural log functions. So this whole line is just what we'll substitute in for this portion of the original problem. So we'll continue with the original problem again. So we have 3 times the natural log of 1 plus e to the x, that quantity squared, times the derivative of this expression, which is e to the x over 1 plus e to the x. And then simplifying, combining everything together, we have 3 e to the x times the natural log of 1 plus e to the x, that quantity squared, over 1 plus e to the x. So there are situations where we'd have to apply the chain rule multiple times. In this case, we applied the chain rule twice. It's possible we can encounter that 3, 4 times. So probably twice is the most we'd ever have to encounter that. But anytime we hit the derivative of another composite function, we just, again, come back to those general properties of differentiation or the chain rule, whichever way you want to think of that.